Hello everybody, it's Mrs. Pound and I am back with Chapter 6 on Periodic Table and Elements. We're starting a new chapter today from BJU's Chemistry's 5th edition. The first section we're going to talk about is Section 6.1 on the periodic table. Our objectives today will be to describe the development of the modern periodic table, describe the information on the periodic table including cell data, periods, and groups, and to identify the regions of the periodic table occupied by metals, nonmetals, and metalloids. So the periodic table, which we've already been using some, is a table of all the known elements ordered by increasing atomic number and arranged in a manner that models the atomic structure of the elements. And we've already started talking about that with the S, P, D, and F blocks and how the period numbers on the side of the rows corresponds to the principal energy level. So we've actually started getting into some of this. Now, the first attempt at kind of the periodic table was by Antoine Lavoisier. He was French, and he published the first list of elements in 1793. It looked nothing like we have today. It was just a list of elements that he had isolated, and actually not all of them were elements. Some of them were compounds. Most of the compounds that he had listed were oxides, and he had refined them to the point that they were oxides, and he couldn't get them to break down further, so he thought that they were elements. But this was a first attempt, and a pretty good attempt. Then Johann Dobereiner grouped elements with similar properties into triads in 1829. So he noticed that there were certain elements that had very similar properties. So this was the starting of grouping elements together. And again, he still had some compounds in there that he did not realize could be broken down further. Then there was John Newlands. He arranged the elements according to increasing atomic masses and thereby discovered the relationship that he called the law of octaves in 1864. And this really goes with what we're going to call the octet rule with our valence electrons. So he had discovered this property that elements with the same number of valence electrons had very similar chemical properties. Now, the one you might actually be familiar with is Dmitri Mendeleev because he's credited with developing the first ordered table of elements arranged still again by atomic mass. They did not know anything about the atomic number right now, about protons in 1869. And the interesting thing about Mendeleev's periodic table is there were gaps in the table. And so he predicted that there were missing elements that would be discovered at a later time, and his predictions were correct. They later found elements that fit in the spots that he had said there should be one. Then finally, Henry Moseley, his work with X-rays resulted in the revision of the periodic table and the atomic number being used as the organizing factor for the elements of the periodic table in 1912. So this is really more where our modern periodic table comes from. The one that we are most familiar with was Moseley and his work with atomic numbers. So now we're working with the number of protons instead of the atomic mass because there are a few instances on the table where the elements are not ordered in order of increasing atomic mass, just due to the number of neutrons. So there are a few places, so maybe you can find some of those. And he developed the periodic law that says the properties of elements vary periodically with their atomic numbers. Now, on the periodic table, too, there are what we call the uranium elements. This is an element with an atomic number greater than 92, the atomic number of uranium. The first 92 elements of the periodic table are natural. After that, they are man-made. They are created through experiments by basically colliding atoms and using particle accelerators to create new elements. They are not natural and they are radioactive, all of them. Now, the information in the cells, typically on your periodic table that I have given you, you will see the symbol, the atomic number, the atomic mass, the electron configuration, and the oxidation states. And those things, for the most part, except for oxidation states, are shown in the picture in the background. So here is your periodic table, and as you can see, there is a key, so you can always know what they are. You have your atomic mass in the left, your symbol here in the center, atomic number, which is the number of protons, the electron configuration, oxidation states, which will be helpful when we're learning how to write formulas for compounds. And so that is what is on your table. It does not have the name of the elements, but you know that you can find that on the next page. So the periodic table is arranged by groups. This is a column of the periodic table that includes elements that have similar properties because they have similar electron configurations, and they're sometimes called a family. And we've done the family project, and we saw that for the most part, they all have the same number of valence electrons in their groups, and we talked about how to do that. It's by the group number. Groups 1 and 2 have 1 and 2 valence electrons respectively. 13 through 18, you drop the 1 off of the front of the number. So here, the columns up and down are the groups, and it's labeled right here, group, in case you forget, group, group. Then there's also the period. This is a row in the periodic table that includes elements that have their valence electrons in the same energy level. The period number represents the valence shell, and sometimes we also call these a series. So period is labeled here, so the periods are the rows going across, and we have already covered that. Periodic features of the elements on the periodic table include the principal energy level, the orbitals, and the electron configuration. So metals. Metals are usually solid, lustrous, shiny, malleable, and ductile, and they are good conductors of heat and electricity. And they are to the left of the stair-step line on your periodic table. So if we take a look at the periodic table, do you see this dark stair-step line that looks like stairs? That is the line I am talking about. And everything to the left is a metal. So most of the elements on our periodic table are in fact metals, the large majority of them. The transition metals, groups 3 through 12, are the D block. So these are the transition metals. And for the most part, if you look at the oxidation state of most of them, some of them have different numbers, but in general, it's usually you see a +2 there, so they generally have 2 valence electrons. Now, the exception to them being solids is mercury. Mercury is a liquid at room temperature, and because of its properties as a liquid, we often use it in thermometers. Nonmetals are generally gases or soft, crumbly solids and generally poor conductors of heat and electricity. They are to the right of the stair-step line. So again, here is our stair-step line, right there. There are these elements over here. Also, we would include hydrogen there in with that as a nonmetal because it's a gas. Although if you cool it, if you bring it down to a low enough temperature to just about absolute zero, it will have metallic properties. Then there are metalloids. These are semiconductors which have properties between metals and nonmetals. They're along the stair-step line. These are generally used in our electronics. There's boron, silicon, germanium, astatine, antimony, tellurium. Those are metalloids used in our electronics and computer industries. They're not as conductive as metals, but they do have some conductivity, so they're very useful, and we wouldn't have our electronics without them. So our objectives today were to describe the development of the modern periodic table, describe the information on the periodic table, including cell data, periods, and groups, and to identify the regions of the periodic table occupied by metals, nonmetals, and metallites. Don't forget your 5 questions in your notes, and I'll be back with more from Chapter 6.